course for commercial mechanical inspector M2, and now we are in module number 7. This for duct system. Recommended study time is 240 minutes. Module 7 requires reference International Mechanical Code 2021 or later. For example, 2024 or before this. It's okay, it's accepted. All is the same, not too much difference. It is in this module about chapter 6. Okay, we will talk about duct systems. As we see here, this is duct systems. Okay, illustration 7a duct systems. This module covers the material and the method of the construction and installation of ducts, plenum control, exhaust system, and fire protection system that relate to the building air distribution.
Studying duct systems. Chapter 6 of the IMC regulates the materials and methods used for constructing and installing ducts, plenums, system controls, exhaust systems, fire protection systems, and related components that affect the overall performance of a building's air distribution system, and the reasonable protection of life and property from the hazards associated with air-moving equipment and systems. This chapter contains requirements for the installation of supply, return, and exhaust air systems. Specific exhaust systems are also addressed in Chapter 5 and covered in Modules 9 and 10.
Understanding the code. Information on the design of duct system is limited to section 603.2. The code is very much concerned with the structural integrity of the system and the overall impact of the system on the fire safety and life safety performance of the building, but design consideration such as duct sizing, maximum efficiency, cost effectiveness, occupant comfort, and convenience are responsibility of the design professional. General duct system requirements, International Mechanical Code 2021, Section 601. Chapter 6 launched right into some specific requirements for duct system and their interaction with corridor and egress path. Let's start off by reading through a simplified list of some of requirements. Air in corridor. Illustration 7b, corridor and air movement. Corridor itself is not permitted to be used as mean to moving, but there are few exceptions. Study tip, where corridor can be used to move air as make up air to exhaust space, such as bathroom, as long as the corridor is provided with adequate outside air, inside a dwelling unit, inside tenant space 1000 square feet or less, incidental air movement from pressurized room within healthcare facilities. As we see here illustration 7c, transfer air to bathroom. An exhaust fan for this bathroom pulls air through the grill in the ceiling of the hallway to provide makeup air to the bathroom. In reality, corridor end up moving a lot of air in building. Pressurized air from supply diffuser like water will take the easiest path, and that easiest path is often the corridor. Think about it. If the door from the room to a corridor is open, the air will have less resistance moving through the door and in to various return air pathway, then through the return grill in the room, and those through the plenum of ductwork. Some air will naturally go through the corridor and some will go through the provided return air pathway. The idea here is that there is a dedicated path for moving air that it is not the corridor. Air above corridor ceiling. When designing mechanical systems, pathway for return air must be planned and routed. The ceiling of the corridor can be used as a return plenum, but under certain conditions. Let's let's take a look at these conditions listed in the code study tab. Conditions for using a corridor ceiling as return plenum. If the corridor is not fire rated, if the corridor is separated from the plenum by fire rated assembly, if the air handling system serving the corridor is shut down when some is detected in the return air, note that this is already a requirement for the unit larger than 2000 CFM C606.2.1. If the air handler shuts down when sprinkler water is detected in the corridor, if the plenum above the corridor is part of smoke control system, ventilation of exit enclosures. Okay, this ventilation of exit enclosures. International Mechanical Code 2021, section 601.3. This is exit. Illustration 7D, exit enclosure. This exit enclosure have special requirements that we'll want to look at. Let's look at several methods used to provide mechanical ventilation in the exit. Okay, this exit enclosure. And here equipment and duct outside of building and shaft enclosure. Illustration 7E, outside the building, equipment and duct work can be located outside of the building and directly connected to the exit path enclosed in the shaft construction. Illustration 7F in the exit enclosure. Okay, this exit enclosure, and here equipment and duct work in the exit enclosure. Equipment and duct can be located in exit enclosure with air taking and exhaust discharge directly from and to outdoor or conveyed through shaft. Illustration 7G, inside the building, located in the building, the equipment and ductwork have to be separated from the rest of the building with shaft construction. Here, equipment and ductwork inside building isolated from interior with shaft enclosure.
Methods of mechanical ventilation of an exit enclosure. Ultimately, all of the mechanical methods of ventilating exit enclosures are the same, as in all the mechanical equipment will be a part of the exit enclosure. In all the scenarios, the exit enclosure contains the equipment because the exit enclosure is separated from the building, and so is the mechanical equipment, regardless of where it is actually located. If the equipment and ductwork are located outside of the enclosure is extended using shaft construction to make the enclosure contain the equipment and ductwork. In all cases, when openings are required through the fire-rated construction, they should only be provided for maintenance in operation and should be self-closing.
Illustration 7H, exit enclosure ventilation. Most often exit enclosure are ventilated using natural ventilation by getting ventilation air from the exit door in In that case, no ductwork is necessary. Contamination prevention. International Mechanical Code 2021 Section 601.4 to Section 01.5, we cannot allow return air cycling through the plenum to become contaminated. This could happen with the introduction of pressure change in addition to being close enough to a nearby chimney, for example. Understanding design to avoid contaminating return air in plenum, exhaust duct under positive pressure, chimney, and vent are not allowed to go through plenum unless a special condition applies. Special conditions for routing a duct or vents through plenum. The code does not allow exception to the above rule should one of the following conditions apply. One, the exhaust runs through a plenum over space permitted to have 10% recirculation. Spaces like art, classroom, science laboratories, locker room, woodshop, shower room, and restroom. Number two, the vent is meant for positive pressure and sealed. Number three, vent fittings and joints are not located or don't land within the plenum. Number four, the vent is inside a sealed conduit or enclosure inside the plenum. Return air consideration. Return air has code requirements that must be followed, such as this one. The amount of return air cannot exceed the amount of air supply. This is a fairly obvious requirement, but calculation done ahead of the time ensures this doesn't happen. There are other requirements that also apply. Let's study them. Distancing. The return air opening must be at least 10 feet away from combustion chamber or draft hood of an appliance. Note that this prevents return air from completing with combustion chamber or draft hood. Resources. Return air cannot pull from hazards or unsanitary location or other specified location. This list includes the following: refrigeration room, closet, bathrooms, toilet room, kitchens, garage, boiler room, furnace room, unconditioned attic space or directly from a crawl space, indoor swimming pool enclosure or associated discs, unless a humidifier is used or the air channeled to be dedicated system. Dwelling unit interaction. Return air also cannot be taken from one dwelling unit and discharged
Understanding
into
return
another.
air requirements. These general requirements for return air are explained in more detail in Module 8, 9, and 10 when we go over ventilation and exhaust. Remember that all of these requirements are to prevent contamination.
Plenum. International Mechanical Code 2021 Section 602. Air plenum are spaces used to transfer supply, return, exhaust, relief, or ventilation air. They are limited to uninhabited crawl spaces, areas above the ceiling or below floor, attic space, mechanical room, and
The concern
framing
of smoke and
cavities.
flame spread. Just
Okay.
like positive pressure exhaust, ducts, and chimneys are not allowed in air plenums, fuel-fired appliances are also prohibited in order to prevent contamination and unobserved fire spread. While flame and smoke in the plenum are obvious contaminants, there is an additional concern about spreading fire with a plentiful amount of combustion air in a location that is not occupied. Fire could spread far in a plenum before it is even noticed by building occupants.
Fast facts. All material assemblies inside a plenum must have a flame spread index of 25 or less and smoke developed index of 50 or less, ASTME 84 or UL 723. It is important to be aware that this requirement does not apply to 1 and 2 family dwelling or smoke detectors, or if the material is isolated from the plenum by non-combustible
Flame
raceway
and
or
smoke spread
enclosures.
indexes. Usually, when a rating is called an index, it means that the rating is based on some kind of standard. In the case of the flame spread and a smoke developed index, 0 is assigned to inorganic reinforced cement board, while red oak is the standard for 100. Most other materials will fall in between. Note that flame and smoke spread materials are also discussed in the SI CERT's commercial building course in depth. The testing process for flame and smoke ratings. How does the testing process work? When a material is tested, a sample 20 inches wide and 25 feet long is installed on the top of a tunnel. A constant gas flame is applied to the material on one end, and the rate of flame spread is compared to the two standards, cement board and red oak, and given a rating based on how they compare. The smoke developed index has the same standards with the same values, but the amount of smoke generated as a material burns is compared to the standards here.
Gypsum board. Can gypsum board used to form a plenum? Illustration 7I. Gypsum for plenum. Gypsum board can be used to form plenum so long as certain air temps and humidity remain limited. Air temps must be remain below 125 degrees Fahrenheit and surface temperature must remain above the dew point of the airstream. Understanding the field. Gypsum made plenum are not allowed in systems using evaporative coolers, cables, wires, and piping within plenum. Plenum can serve as medium for housing item within. Here are some things you may find running through a plenum: wires, cable, optical fiber, communication cables, plastic sprinkler piping, combustible pneumatic tubing, plastic plumbing, piping, and tubing. Regardless of the list of items above, the requirements for any of them found within a plenum are same. Wires, wire cables and piping requirement in plenum. The peak optical density cannot be greater than 0.5. The average optical density can be greater than 0.15. The flame spread distance cannot be greater than
Differing
5
from
feet.
smoke and flame indexes. Optical density and flame spread distance are not the same as flame spread and smoke developed indexes. Let's look at these differences and understand the distinctions.
Optical density and flame spread distance are terms that come from NFPA 262 test for wire and cables and tubing. Optical density is referring to amount of smoke that produce when the material is burned. Understanding practice. NFPA 262 is similar to ASTM E84 mentioned above. The wires as laid in a single layer on a cable tray 25 feet long and 11.25 inches wide, and ignitions with a gas flame on one end. Instead of using an index, a photoelectrical eye measure optical density at the outlet of the chamber, and the flame spread distance is measured after test of 20 minutes. Metallic enclosure. Electrical equipment with metallic enclosure exposed with plenum is permitted, but combustible enclosure, discrete plumbing, and mechanical products must be listed for plenum use in accordance with UL 2043. Here, condensate pump. Illustration 7G, condensate pump installed in plenum. Discrete plumbing and mechanical products installed in plenum must be listed for plenum use. Foam plastic. Foam plastic can be used in plenum so long as certain code requirements are met in order to mitigate the potential smoke and flame spread. Foam plastic can have a higher flame spread index, up to 75, and higher smoke develop the index up to 450 if it's separated from airflow in the plenum by one of the following. 1. Thermal barrier complying with IPC 2603.4. Corrosion resistant steel at least 0.016 inch thick, 1 inch of masonry of concrete. Stud wall cavities and floor joists. Stud wall cavities and spaces between floor joists can even be used as air plenum, but of course there are conditions to be met. Study tip: conditions for stud wall cavity and floor joist plenum. They cannot be used for supply. If the stud wall is a part of the required fire-rated assembly, then using it as a plenum would not be permitted. Plenum are where air transfer. If it is fire rated assembly, we cannot have mechanically induced airflow. They cannot convey air from more than one level. They must comply with IBC, International Building Code, floor penetration protection. They must be isolated from adjacent concealed spaces with fire blocking as required by IPC. They cannot be used in outside wall. Duct construction and installations, International Mechanical Code 2021, Section 603. Ducts are used to distribute air in building. For easy reference, refer to the table below when considering duct sizing. This table for aspect of duct and for the reference. For example, let's take metallic duct construction. It's according to Smagna H duct construction standard, metal and flexible, and so on. Illustration 7K references for duct sizing and construction. Take note here that the International Mechanical Code refers to the source for nearly everything about duct sizing, construction, and installation. Duct classification. Ducts are classified based on the maximum operating pressure of the duct. The classification are limited by the code to positive or negative 0.5, 1, 2, 3, 4, 6, 10 inches of water column. The classification used must be above the design pressure requirements for specific duct material. International Mechanical Code 2021, Section 603. Illustration 7L, metallic duct, round duct require at least 3 screw or rivet. Yeah, this very important information that round duct require at least three screw or rivets spaced equally around joints, or equally spaces on the exposed portion without a hang effect. Crimp joint must be lapped at least 1 inch. This is important information also, that crimp joint must be lapped at least 1 inch, and male end of duct should extend into the next duct in the direction of airflow. Illustration 7M non-metallic duct 603. According to the code, air temperature in non-metallic duct is limited to 250 Fahrenheit. Gypsum board can be used to form air ducts with the same requirement as gypsum in plenum return air reference further up to the module if needed. Air ducts and air connectors. What is the difference between flexible air duct and flexible air connector? Flexible air duct, flexible air connector. Illustration 7N flexible air duct and flexible connector. 603.6. Both air ducts and air connectors are tested per the UL 181 standard. Let's look at the code-related differences between the two and then understand how to differentiate. Practically, testing air ducts are required to pass 15 UL 181 tests. An air connector is only required to pass 12. Air connector are not required to pass UL 181 impact, small scale flame penetration, or small scale flame impact test. Understanding the code, as a result, air connectors can only be installed in lengths of up 14 feet. There are no installation length restriction on air ducts. Connection and travel. Connectors are used to connect rigid duct sections together, primary for vibration isolation, or for locating terminations in alley and ceiling. Also, connectors can not pass through a wall, floor, or ceiling. Understanding the field. You can tell the difference between a connector and a duct primary by the product labeling. Requirements for duct applications. International Mechanical Code 2021, Section 603. Underground Duct 603.8. Ducts can be installed underground or within 4 inches of ears, with slope at least 1 by 8 inch per foot to drainage point with access. Fast facts: if metallic ducts don't have protective coating, they need to be encased in at least 2 inches of concrete as a corrosive protection measurement. Illustration 7O plastic ducts. Plastic duct must be PVC, 8 psi stiffness at 5% deflection. And can only be used underground with a temperature limit
Protecting materials.
of 100.
Section 603.12 through 603.16 talk about protecting materials. Protections such as preventing condensation from forming on the exterior of any duct, preventing cars from running into your ducts, protecting ducts from weather and flooding, and so forth.
Illustration 7b Air dispersion system 603.17 air dispersion system such as a permeable fabric duct are required to be completely exposed
Exposed and
and
under
under
positive pressure.
positive pressure.
Fabric duct is permeable and is used for air distribution on all sides. It is often used for distributing air in large open spaces, such as gymnasiums, arenas, natatoriums, or swimming pools. They are not subject to the same kind of damage as metal ducts. If a ball hits them, they simply bounce off. Fabric ducts have to be under positive pressure because if they are placed under negative pressure, they would get sucked into the connecting ductwork. Fabric ducts need to be exposed so that rips are obvious, and also so that they are not getting compressed or blocked off in a hidden ceiling space. A nice benefit for sports arenas: the fabric can be screen printed with team logos or other messages, and they can be removed, usually with zippers, and cleaned in commercial washing machines.
Grills, registers, and diffuser. International Mechanical Code 2021 Section 603.18. What is the difference between a grill, a register, and a diffuser? Let's take a look at each. There is some overlap between the three. Because of this, they are often lumped together and referred to as GRDs, grill register diffusers. Here, illustration 7Q grills. A grill has a fixed plate and no integral damper. A grill works for return, exhaust, and supply. Illustration 7R register. A register is the same as grill, except that a register has adjustable damper that can control the airflow direction or shut off flow completely. Illustration 7S diffuser. Diffusers are typically designed to distribute air all around or have direction variability. They are used to distribute air with fixed directional plates. Understanding design, registers and the diffuser are built for supply. Volume damper. Illustration 7T showing volume damper. Accessible volume damper or other means of adjustment are required at each branch duct, register, grill, or diffuser. The volume damper allow airflow to be balanced between individual GRDs. Flow register weight test. This floor register. Illustration 7U flow register weight test. Floor registers are used to distribute supply air from the floor. They should be able to withstand 200 pounds on 2-inch diameter disc. Apply to the most critical area. Floor registers are not allowed in toilet room or similar space except in dwelling unit. Nobody want to clean up that mess when the toilet overflow. Duct installations. This International Mechanical Code 2021 Section 604. Enough duct installation is required to bring exposed surface temperature to 120 degree Fahrenheit for hot air or above the dew point for cold air. This code requirements inhabits continual consideration and make the service safe to touch. Understanding practice. Ducts can be installed with an external wrap or an
Insulation labeling. Every
internal
36
line
inches, insulation should be
insulation
labeled with the name of the manufacturer,
labeling.
the R value at that specified thickness, and the flame spread and smoke developed indexes.
Here, illustration 7U duct insulation exterior wrap. Duct insulation is used to save energy, protect from consideration, and avoid temperature degradation. Duct covering are not permitted to go through a fire-rated wall or floor. Illustration 7W duct lining interruptions. Duct lining are interrupted at fire number within 6 inches of electric or fuel burning heaters and immediately downstream of the cooling coil. Illustration 7X duct opening. Opening in the duct should not be covered unless the exact location is identified. At this label fire rated partition, you can see fire number on the right, a duct access or door not covered by insulation, and the duct covering this area that stop before going through the firewall, both in left. So the fire number is not insulated, and here is the duct. If it's passing through a fire rated wall, it will not be insulated in this area. Air filters, International Mechanical Code 2021 section 605. All air must be filtered upstream of any heat exchanger or coil. Filters must be installed in a convenient location since they have to be changed regularly. Illustration 7Y high efficiency filters. High efficiency filters often look like bags, so there is more surface area and less pressure drop. Do you know filters should have even air distribution over the entire filter? Illustration 7Z Biocid UV filters. UV light kills many bacteria and viruses. Here, the UV filter is installed downstream of two other filter banks and does more sanitizing than filtering. Smoke detection control over duct system. International Mechanical Code 2021 section 606. Air distribution system over 2000 CFM requires smoke detector except where the system cannot spread smoke beyond the enclosure of space where smoke is generated. Smoke detector here. Illustration 7AA duct mounted smoke detector. Smoke detector must be installed upstream of all filter decontamination equipped and outdoor or exhaust air connections. In this case of a return air riser serving more than one story and with capacity greater than 15,000 CFM, each story required a smoke detector upstream of the connection to the riser. Example 1. Two communication rooms are separated by mechanical room. The mechanical room has two computer room air conditioning CRAC units, one for each communication room. Each CRC unit supplies 1500 CFM with a common return. Are duct smoke detector required? Yeah, they will. The common return makes the two units become one air distribution system. The system supplies 3000 CFM of conditioned air, which is higher than 2000 CFM that makes smoke detector required if the return was ducted and there is for isolated for from each other, smoke detector would not be required. Example 2. In the same scenario as the previous example, the units are now increased to 2500 CFM each, and the return air ducts. Are duct smoke detectors required? No, they are not. Each unit cannot distribute some smoke to any enclosure besides the communication room that it serves. Because the unit is fully ducted and sealed,
Monitoring
therefore
airflow.
smoke detectors are
Duct-mounted
not
smoke
required.
detectors must monitor the
Monitoring
entire airflow conveyed, including return air and exhaust or relief air. Should a smoke detector become activated, the detectors should shut down the air distribution system and activate smoke control modes to prevent spread.
Think about it. If all areas served by a system are protected by area smoke detector connected to fire alarm system, additional smoke detectors are not required at each return duct. Duct and transfer opening in rated building assemblies. International Mechanical Code 2021 Section 607. This section is about protection of air transfer opening in protected building assembly such as fire-rated wall.
Understanding air transfer
air
openings.
transfer
The IBC dictates where
opening.
fire-rated walls and other assemblies are needed and what their rating should be in units of the time it takes for the fire to get through the wall or assembly. Ducts that penetrate rated assemblies disrupt that rating. In other words, an open duct in a fire-rated assembly provides an opening for fire to pass through from one side of the assembly to the other, and thus bypassing the rating. To protect the rating of the assembly, fire dampers are used inside the duct. Fire dampers will automatically close when the duct gets hot enough to melt the link holding the damper open.
Fire damper. Illustration 7a fire damper. Fire dampers are spring-loaded to close when the solder on the fusible link melt. Shaft. Illustration 7ac shaft protection. Shafts are opening passing between multiple floors, normally vertical. Shafts must be protected in shaft enclosure so the fire cannot travel between floor quickly from chimney effect. Understanding the code. A duct passing horizontally from one shaft to another will not require a shaft enclosure in the penetration into each shaft is protected with damper. Walls. Illustration 7AD sealing the annular space. Certain fire-resistant rated wall don't require fire damper for duct penetration. The annular space is still required to be sealed and protected as described in International Building Code 714 for walls and International Building Code
Other exceptions for
717
using fire dampers.
for
There are also
floors.
exceptions for using fire dampers in
Other
ducts that are
exception,
part of an IBC 909 smoke control system or part of a hazardous exhaust system, if the dampers will interfere with the system function.
fire damper actuation, International Mechanical Code Section 607.3.3.1. Fire damper installed in less than 3-hour fire resistance rated assemblies are required to have 1.5 hour minimum rating. Fast facts: in 3 hours or greater assemblies, the fire damper are required to have 3-hour rating. When should the fire damper actuate? Fire damper should actuate approximately 50 degrees in height above normal operating temperature, but not less than 160 degree Fahrenheit and not more than 350 degree Fahrenheit when in an International Plumbing Code 909 smoke control system. Did you know fire dampers are simple devices? The damper is set on strong spring that is forcing it to close, but until actuated, uh, is held open by metal bracket that is soldered in place. The solder is selected based on the melting point to match the actuation temperature. When the solder melts, the damper is actuated by spring and damper shut quite forcefully. The solder connection is called fusible link. Smoke damper actuation. International Mechanical Code 2021 Section 607.3.3.2. Let's look at smoke damper actuation. Smoke damper close when the required smoke detector activates in one of the following scenarios. Study tip. Smoke detector require 4 damper actuation. Number 1, for a smoke damper inside duct, the smoke detector is within 5 feet of the damper. For number 2, for a smoke damper installed in a smoke barrier, a spot type detector should be installed on either side of the door opening. Number 3, for smoke damper installed in an unducted opening in wall, a spot type detector should be installed with 5 feet horizontally of damper. Number 4, for a smoke damper in a corridor, a smoke detection system in the corridor can control the damper. Smoke dampers can also be controlled by smoke detection system when installed in all areas served by the duct. Smoke dampers are powered devices, while fire dampers are not. When smoke is detected, the actuator is commanded closed by central alarm panel. By adding spring and fusible link to the smoke damper, it become an combination fire smoke damper. Illustration 7a smoke damper. Some dampers are closed by spring when the power to the damper is lost. Power is turned off when the associated smoke detector is activated. Understanding the field. The cost of combination fire smoke damper is so similar to the smoke damper that designer and engineers will often specify a combination damper where only a smoke damper is required. Specifying combination damper only help avoid confusion between the combination damper and smoke damper. Some smoke dampers don't get installed where combination damper are required. Sapphire damper, and this is the axis for sapphire damper. Illustration 7AF axis and identification. Fire and smoke dampers must be accessible with access point labeled with letters at least 0.5 inches in the high reading fire smoke damper or fire damper. You can see the specified in section 6074. Damper requirements for wall barriers and penetration. International Mechanical Code 2021 section 607.5. The SI CERT's commercial building inspection course goes into great detail teaching about firewalls, fire barriers and fire partition and smoke barriers. These concepts are important to understand for the building inspector. We, we will give brief overview of each here and then talk about the number requirement listed in the International Mechanical Code for each assembly. And Firewalls in Chapter 2, definitions in the International Building Code. The definition for firewalls roads. A fire resistance rated wall is a wall having protected opening which restricts the spread of fire and extends continuously from the foundation to or through the roof, with sufficient structural stability under fire condition to allow collapse of construction on either side without collapse of the wall. Illustration 7AG, the fire resistance rated wall. There are 4 key points found in the above definition for fire resistance rated wall. Reference this illustration as you read through them below. Study tip: 4 key points of fire resistance rated wall. The wall is continuous from edge to edge of building. The openings are protected or rated. Number 3, the wall is rated for a certain number of hours. Number 4, the wall is structurally independent from either side. Firewalls are typically a complete separation assembly, meaning each portion of building separated by firewalls is considered a separate building. Openings are generally not allowed with some exception and additional code-driven regulations. Understanding design: building can be divided into 2 or more manageable zones to contain a fire for the time required. In the International Building Code, occupants have better chance to evacuate or move into a protected zone. Numbers used in a firewall: openings that are permitted in firewall. Reference International Building Code section 706.11. Get fire number: opening in firewalls that serve horizontally exits get smoke number. Fire barriers in Chapter 2, definitions in the International Building Code. Fire walls are defined as follow: a fire resistive rated wall assembly of material designed to restrict the spread of fire in which continuity is maintained. So what is the difference between a firewall and a fire barrier? Understanding design: both try to contain or control the spread of fire, but firewall is usually a higher rating and is self-supporting, allowing the building on one side to collapse without compromising the integrity of the wall. Here, concept of firewalls. Okay, A extend 18" beyond plus beyond the exterior. P extend 4 feet from wall on interior. Concept of fire barrier. Fire barrier is rated partition within the building. Illustration 7AH, comparing the firewall and the fire barrier. The fire barrier is generally supported by the structure members and not self-supporting. Its structure must be equal of better rating than the firewall. Study tip: firewalls often separate 2 unique buildings or ownership. Fire barriers separate single building into protected area. Understanding the code: like firewalls, fire barrier have strict regulation on opening, penetration, duct, and air transfer. Opening, all of which must be rated. Joints are also regulated. Again, the most restrictive or highest rating shall apply if two different ratings are present. Numbers using in fire barrier ducts cannot penetrate enclosure for exit, stairways, ramps, and passageway except as used for independent ventilation or pressurization. An opening in the fire barrier of a horizontal exit get a smoke damper. Opening in fire barrier get fire damper except if any of the following apply. Number one, penetration are tested as part of the fire-rated assembly STM E119 or UL29263. Ducts are a part of smoke control system and fire damper would interface section 513. The HVAC system is fully ducted. The fire rating is 1 hour or less, not group H occupancy, and there is an automatic sprinkler system throughout IPC 903.32.1. Fire partition in Chapter 2 definition in the International Building Code, fire partition are defined as vertically assembled or materials designed to restrict the spread of fire in which openings are protected. Thus, fire partition is somewhat of a step down from a fire barrier. Let's summarize the important characteristics of fire partition. By doing so, it will help us understand its place among the other rated assembly. Study tip defining characteristics of fire partition. A fire partition is always vertical, while a fire barrier may be horizontal. A fire partition is generally continuous from the foundation or the floor to bottom of the roof or ceiling assembly above. There are exceptions. Fire partition are commonly used to separate spaces in the following: covered and open malls, corridor walls, enclosed elevator lobbies, and egress balconies. They usually have a rating of 1 hour, but certain exceptions allow 30 minutes. In some conditions, fire blocks and draft stops are required to prevent fire from having a chimney effect upward. Fire partition versus fire barrier. Fire partition vertically only 30 minutes up to 1 hour, and fire barrier is both horizontal and vertically 1 hour up to 4 hours. Illustration 7AI, the fire partition and fire barrier. When we look at the two in comparison, we can see where is the differences lie in form and function. Building classifications, quick overview. Quickly let's pull in summary of the various building classification found in IPC. If you have your IPC, you can reference the listed sections for more study. The building code has primary classification for all new and existing building. In the listed section, you can see many examples of building and structures for each of the primary classification. Study tip: primary building classification for Group A assembly, Group B business, Group E education, Group F factory and industrial, Group H high hazard, Group I institutional, Group M mercantile, Group R residential, Group S storage, Group U utility and miscellaneous. Damper used in fire partition. Now let's continue with damper. Fire partition get fire damper in occupancies other than Group H. Fire dampers are not required if any of the following apply. Number one, barrier walls have automatic sprinkler throughout CIPC 903.3.1 as desired. In addition to ducting being protected as throughout penetration, see International Building Code 714 as desired. Number two, tenant partition are presented in covered and open mall building. Number three, the duct is not more than 100 square inch is and at least 0.0217 inches thick and with no opening in adjacent spaces. Also, it should not be terminated at a wall register in a rated wall and have a 12-inch steel sleeve at each duct opening. The requirement is unlikely to be completely met, mostly because ducts under 100 square inches that don't have opening are rare in commercial building. The HVAC system is fully ducted. Number four, the fire rating is 1 hour or less, and there is an automatic sprinkler system throughout. See International Building Code 903.3.1 as desired. Smoke barrier. From our Chapter 2 International Building Code definition, a smoke barrier is a continuous membrane, either vertical or horizontal, such as a wall, floor, ceiling assembly, that it is designed and constructed to restrict the movement of smoke. Smoke is contained through the use of smoke barriers and smoke partitions. Defining terms. Smoke partition is similar except it is a vertical partition that extends from foundation or floor to the underside of the roof ceiling, also acting as a smoke barrier. Both are designed to restrict the passage of smoke. Smoke partition versus smoke barrier. Smoke partition, not rating required, may terminate at ceiling if ceiling limits smoke. Any wall in area that is sprinkler protected is a smoke partition, not some proof. A smoke barrier from 1 to 2 hour rating, restriction passage of smoke, maybe walls, ceiling, and floor assemblies, continuous. Illustration 7A-G, smoke partition and smoke barriers. Smoke barriers have a 1
Continuity is
hour
the key
rating, but
with
smoke
smoke
partition are
protection.
not required to be
Think continuity
rated.
when you think of smoke protection.
Okay.
This means that joints, openings, ducts, and penetrations must all be rated to give adequate protection. Windows and fire partitions must either be sealed or automatically closing. Doors and fire partitions are regulated to control the passage of smoke. For example, doors with louvers are not permitted because smoke would easily pass through the slat openings.
Dampers used in smoke barriers, opening in smoke barriers walls or corridor enclosures get smoke dampers except in the following cases. 1. The building has some control system throughout, and some dampers are not necessary for the operating and control of the system. Smoke dampers are not required in a smoke barrier penetration where the duct openings are in single smoke compartment and the ducts are made of steel. Smoke barrier. No smoke dampers required at this smoke barrier Duct exit smoke compartment here. Duct has opening in the smoke compartment, which is what allows it to have no damper at the smoke barrier. No smoke dampers required at the smoke barrier. Duct enter smoke compartment here. Illustration 7AK. Smoke dampers are smoke barrier penetration. Expounding on point 12 above. In other words, a duct can cut through a smoke barrier and then return through the smoke barrier into the same smoke area without smoke damper. Smoke dampers are not required in corridor penetration, whereas the duct is constructed of steel at least 0.019 inches in thickness, and there are no openings serving the corridor. Smoke dampers are not required in some barriers of International Building Code 407.5 for Group I2, Condition 2, with fully ducted HVAC, automatic sprinkler also throughout, and with quick response sprinkler reference International Building Code 903.3.1.1 and 903.3.2 if desired. Study tip: remember that we are looking for awareness of comprehensiveness of the code along with some understanding of what we are reading. We are not trying to memorize of all of these specification and exceptions. You got this. Let's continue as we are close to wrapping up this module. Shaft enclosure. Remember that on the list of vertical opening are shaft enclosure, vertical opening, illustration 7A, vertical opening. Vertical opening is on floor or roof assemblies such as stairs, elevator, and escalator opening. Duct, atrium, chimney, and shaft enclosure are highly regulated. They could easily allow the rapid square of fire or smoke to adjusting floor. Damper used in shaft enclosure. Shaft enclosure get fire and smoke damper, but fire damper are not required if any of these continuous apply. Steel exhaust subducts extend at least 22 inches vertically in exhaust shafts, provided there is a continuous airflow upward to the outdoor. Number 2, penetration are tested ASTM 119 or UL
Smoke dampers not
263
required.
as a part of the
Smoke
assembly.
dampers aren't required in Group B and
Smoke
R
dampers
occupancies.
not
Or
required.
kitchen, clothes dryer, bathroom, and toilet room exhaust have an exhaust fan at the upper termination, powered continuously, maintaining flow upward to the outdoors.
Neither fire damper nor smoke damper are required if any of these. 1. Ducts are part of IPC 909 smoke control system, and dampers will interfere with the operation. 2. Parking garage shafts are separated from the building shaft by at least 2 hours of fire rating. Number 3, in kitchen exhaust and clothes dryer exhaust, dampers are often prohibited. That includes smoke damper, exterior wall, and smoke partition. Illustration 7 AM exterior wall with fire resistant rating will require fire damper. Remember, a smoke partition is a way to contain smoke. Smoke partition required smoke dampered except where it will interfere with a smoke control system. Horizontal assembly, duct penetrating horizontal assembly think floors required a shaft enclosure. Let's look at some cases in the code where exception can be made to the requirement of shaft enclosure for a duct moving through horizontally. Simply remember to follow along in your code. Number one, penetration for no more than 2 stores and not in I2 and I3 occupancies are allowed without shaft if a fire damper is installed at the floor line or the duct is protected by requirements found in IBC section 714.5. Number two, shafts are not required for up to 3 floors in dwelling unit, 4-inch diameter or smaller, with some additional requirement listed in International Mechanical Code 607.6.1. Ducts that penetrate ceiling membranes of a rated floor ceiling or roof ceiling are allowed without a shaft, with a ceiling radiation damper installed at the ceiling line. Not even, not even the ceiling radiation damper is required if any of these exceptions apply. An assembly test shows that damper isn't required. An exhaust duct or outdoor air duct protected per IBC section 714.5.12 is located in the wall cavity and not passing through another dwelling or tenant space. A duct outlet penetration system is used and tested as a part of the assembly. Non-fire resistant rated floor. Non-fire resistant rated floor penetration are allowed without shaft if only one of the following applies. One, no more than 2 stories, and the annular space is protected with a non-combustible material that resists free passage of flame and smoke. Number two, no more than 3 stories. The annular space is protected and a fire damper is installed at each of floor line. Fire damper are not required in individual residential unit such as 3-story home. We will take the quiz, and here we have 5 questions. If we have any question we don't know, it's okay, we can revise the correct answer together. Crease duct serving type 1 kitchen hood shall be constructed of stainless steel with a minimum thickness of, okay, minimum stainless steel, okay, or steel, get 24, and minimum thickness of 22. Let's see the result. I want to see the result direct. Okay, I want to see the result. It is 18 of steel for crease duct serving type 1 kitchen hood shall be constructed of steel with a minimum thickness of 18, stainless steel 18 and steel of 16. Next question, which of the following is not an option for the ventilation of exit enclosure? From the natural ventilation provided by exit door opening, from mechanical equipment and duct located in the exit enclosure, from mechanical equipment and duct located in the building, from mechanical equipment serving the elevator lobby, no, enclosed in shaft construction. Crimp joints for ground ducts are required to be lapped by 1 inch. Yeah. What is the maximum length of flexible air duct? 14 feet. 14 feet. Of air duct, flexible air duct connector is 14 feet. Next, For supply duct systems that are normally operate at 120 Fahrenheit, what is the operating temperature required for fire damper actuation? We will add it more than 50. So it will be 170, but it must be not less than 160. Yeah, so it's 170. Okay, so by this way we finished here the duct system, and the next one we will study, the next module we will study ventilation together.